Welcome back to Triptych Algebra. Today we're talking about rational exponents. Rational exponents are fractional exponents. Specifically, we want to be able to evaluate expressions that look like this. This is 8 to the 2/3. You hopefully have some previous experience with exponents, but maybe you're thinking, what the hell? Now we have fractions and exponents. They actually aren't too difficult, and we're going to break them down today. As a sneak peek, the answer to this expression, or this evaluates to be 4. What our job now for the next few minutes is to convince you that it makes sense and it is useful to your life. All right, in front of us we have two radical expressions that we need to simplify. And the hope is that you've seen these previously, but here's a quick rundown on how to simplify these. The square root of x to the 8th is x to the 4th. And the reasoning for that is if we take x to the 4th and square it, we get x to the 8th. Let's just verify that here real fast. So if we take x to the 4th and we raise it to the 2nd power, we need to remember that the rules of exponents, we multiply these together to give us x to the 8th. Again, to recap, when we're taking the square root of an expression, what we're looking for is the expression that we would square to get to this exponent. Number 2 is very similar. The difference here is that we have the cube root, not the square root. What we're getting here, we want to do is finding the expression that we raise to the 3rd power. By the way that we do this always is we take this exponent and we're dividing it by the index. If you remember, the square root does have an index of 2. We don't write it in there. This index is telling us the exponent it's related to. So what we do, in this case, if we want to simplify the cube root of y to the 15th, we're going to take y to the 15 and we're going to divide the 15 by this index of 3 here to get that this would be y to the 5th power. Again, before I move on, just to verify this, if I take y to the 5th power and I raise it to the 3rd power, I multiply these exponents together to get y to the 15, which is what I was looking for. All right, now what we're going to do is analyze this step right here. Beautifully and importantly is that division and fractions are always related to each other. This right here between these two expressions is actually the definition of fractional exponents. Let's look at this more closely. If we have y to the 15 thirds, we've already verified that that is the same thing as the cube root of y to the 15th. What we see is that the numerator in this exponent is the exponent here in this radical expression, and the denominator is simply the index of that expression. By the way, we call this form exponential form, and we call this form radical form. When we have in these methods the exponential form when written as a rational exponent, the numerator here is the power or the exponent in the radical form, and the denominator is the index. So let's now generalize this statement right here. If we have an expression that has a fractional or a rational exponent, when we write that in radical form, the numerator is the exponent or the power, and the denominator, the n in this case, would be the index of the radical. We actually can write these in two different ways, importantly. This could be the nth root of x to the m, or we could write this as the nth root of x raised to the m power. The only difference between those two forms is whether the exponent is first inside the radical or on the outside. They're actually equivalent, and it's important to know the two differences as you see different problems. All right then, now we're ready to tackle the expression 8 to the 2/3. What we first do is we take this in exponential form and we're going to write it in radical form. Again, the 2 is going to be the exponent and the 3 is going to be the index. So this becomes the cube root of 8 squared. Importantly, when I do this, when I'm evaluating expressions with rational exponents, I'll use this version, not this version of this definition. And the reason it is, I want to apply the radical to make the number smaller first before I apply the exponent, which makes the number bigger. It won't matter which order you do this. The important thing is a fractional exponent is 2 steps. First, you need to apply a radical, and second, you need to apply an exponent. Not in that order, but those are the 2 steps that you need to do. In this case, I apply the cube root of 8 to get 2, so this expression becomes 2 squared, and 2 squared we know is 4. So that is the justification for why 8 to the 2/3 is 4. Our second example is not much more difficult. The only trick is we now have a negative exponent. If you remember your rules of exponents, negative and exponent just means reciprocal. I will take care of that part first. I'm going to rewrite this, applying the negative exponent to this expression to get 1 over 81 to the 3/4. Remember that negative exponents don't have anything to do with negative values or negative outputs. They simply mean reciprocal or flip the fraction. So I've taken care of the negative. Now I'm going to take care of the fractional exponents in exactly the same way that I just did. This becomes 1 over the 4th root of 81 to the 3rd power. And again, just to hit this point home, I could have written this as the 4th root of 81 to the 3rd, but then the first thing that I would have done is to raise 81 to the 3rd power, which becomes a massive, ugly number. If instead I apply the radical first, this becomes much more manageable. All right, now we need to figure out the 4th root, of 81. That's actually 3. So this becomes 1 over 3 to the 3rd power. And finally, all I need to do is apply the exponent of 3 to this. 3 to the 3rd is 27, giving us 1 over 27, or 1/27th. To simply recap, for rational exponents, there could be possibly now 3 things to take care of. There could be a numerator, which is a power or an exponent. There is a denominator, that's the index of a radical. It's important to understand how to simplify radicals to be able to apply that. And third, you could have a negative exponent, which simply means flip the fraction or take the reciprocal of your expression.